All right. So, when we talk about waves, right, there are, like I was discussing with you, there are a few things that, or a few behaviors that we are only going to see with waves, that, only waves exhibit them. So, let's go ahead and take a look at what those properties can be. So, one of the things, one of the properties that we see specifically with waves, right, is the property that we call diffraction. When we talk about diffraction, what is diffraction? So diffraction is basically the bending of, just once again. Hello, Muad, how are you? Hello, Muad, how are you? Can you hear me?
Oh yeah.
All right, great, Mohan. Okay, so Mohan, today we are actually going over the topic of waves, right? So we are taking a look at the certain properties or certain behaviors that we see in waves. Okay, so we're just starting. Okay, so one of the major properties of waves that we were discussing was diffraction. Okay, what is diffraction? Think of diffraction like this. You guys imagine that you're sitting in a room. Outside you there's someone talking. Now, if the door is right now wide open, if the door is wide open, you guys can hear that person clearly, right? Probably if the person's right outside, there's a good chance that you both can hear them clearly. Now, what is going to happen, that as the door is going to you start to close the door slowly. Okay, as you start to close the door slowly, so that voice is slowly going to get, like lesser and lesser and lesser. And as you close the door, the voice disappears, right? Now, what is actually happening? What is happening is that when you talk about your sound is what? Sound is a wave. Okay? Since sound is a wave, so it can bend around gaps, around gaps or obstacles. Let me give you guys another example. Imagine that you guys are right now looking at a tank of water, right? We're looking at it from the very top. This is our tank of water. Inside the tank of water, you have a small gap. Okay? There is a small gap in this tank of water. We have a wall, let's say. We have a wall like this. And then over here, this is your gap. Okay, so we have our gap and we have the tank of water. How do you guys think? So when the waves are traveling through the water waves, okay, the water waves are moving like in the sea. So when the waves are traveling through this tank, when they're going to reach around this gap, or when they will reach the obstacle, they're not going to continue traveling in the exact same way, right? They're going to have to bend. They're going to have to bend. That bending of waves, that bending of waves through the gap is what we call diffraction. So diffraction is bending of waves around any gap or any obstacle that might be there. A big example of this, a big example of this. Imagine you guys have a glass of water. If you have a glass of water, okay, and in that glass of water, you decide to place a pencil. Now, when you guys will place the pencil inside it, you guys, what are you going to observe? What do you see? You will see that it's going to look like the pencil is bending, right? That's how it looks like. You guys can try this later on if you want to, but when you're going to look through it through the water, it's going to look like the pencil is bending, which doesn't make any sense because you and I know that the pencil is straight. We know that the pencil is straight. We know that it's completely normal, fine. But when you put it in the water, it appears to be bent. What could be the logic or the reason for it? The reason for that is because the light waves are getting diffracted, right? So this is known as diffraction. Making sense what diffraction is? Sasha, Moan, making sense? Any confusion? Any part that's not 100%? Okay. So one of the properties of waves that's really important for us to understand is diffraction, right? Now, there's another property of waves that we need to understand, and that is refraction. Okay, so diffraction is different. Refraction is different. And we are going to study reflection. So reflection, refraction, diffraction, these are three completely different properties. Okay, so you guys have to make sure that do not get confused in between the terminologies. We have diffraction, we have reflection in the syllabus, and we also have refraction. So you have to remember these are three completely different things. Now, when we are talking about refraction, right? In fact, let's first discuss reflection. What is reflection? That's a concept I know you guys already have, right? Reflection is simply when a wave hits any reflective surface and it bounces back, right? That's what it is. It hits a reflective surface and it bounces back. That is reflection. Now, when we talk about reflection, right? Remember this, that when we think of reflection, we think of light, we think of a mirror. But this is not specifically true. All type of waves can be reflected, whether it is a sound wave, whether it is a light wave, whether it is, any other kind of wave, whether it's a wave in a rope, whether it is a wave in a guitar string, all kinds of waves can be reflected. So that is a property of all waves, not specifically related to light. Okay. Now, when we talk about reflection, there are a few things that are really important, right? There are a few concepts that we have to understand. What are the concepts that we have to understand? We have to understand, to make this easy, let's talk about it in terms of let's talk about this in terms of a light. Okay. Okay. So let's talk about this, but let's talk about it in terms of your in terms of reflection. Let's imagine that you and I are looking at a mirror. Okay, this is my mirror. Now, what is going to happen? How does a mirror actually work? The way a mirror works is that the you have your light wave. Okay, your light wave is going to fall onto the mirror. Okay. Now, your eye as the light falls onto the mirror is a reflective surface. So that light is going to get reflected back. Okay. Now, what is going to happen that as the light is going to hit the mirror, now let's say that the object you can see objects in mirrors, right? Like you can use your rear view mirrors, your side view mirrors in your car to see stuff that is even far away. So how does it work? It works like this, that this is where my eye is, okay? And the object that I'm trying to see is somewhere over here. Now, what happens that the mirror image, the image that you guys are seeing, it forms at the back of the mirror. Okay, the image that forms is at the back of the mirror. Okay, and that image is what we are able to see. So the light is going to hit the object. It's going to hit the object, or forget the object. The light is going to hit the mirror. Okay, the light is going to hit the mirror and then it is reflected back into our eye. And I will explain how we can use a mirror to see things. I'll explain that in a bit. But what you have to understand is, now look at this image. Let me draw a line for you guys. This line that I've drawn right in the middle, okay? This line is perpendicular to the mirror, right? Can you guys see that? It's at 90 degrees to the mirror. This line is at a 90-degree to the mirror. Now, what happens is this, that this line is known as the normal, okay? So the line, this is an imaginary line. It does not exist. But this is a line that we use when we are doing calculations, when we're drawing diagrams in the exam. This line is important. We call this line the normal. Now, the light will always be hitting the mirror at a certain angle, right? Whether that angle is completely straight, whether it is hitting it at an angle, whether it is hitting it completely straight on, but it's always going to be making some kind of angle, right? Even if it is hitting the mirror completely straight, it's still going to be at an angle of 90 degrees. So it is always going to be making an angle with the mirror. The light is always going to be making an angle with the mirror. Okay. So there are two angles that you guys have to learn. The first angle that you guys have to learn is the angle we call angle of incidence. Okay. We call this angle the angle of incidence. We write it down with a small I, and it is known as angle of incidence. Right? Now, the angle of incidence is the angle the light makes as it is falling in the mirror. Okay? So, when the light is falling on the mirror, that angle is the angle of incidence. The ray of light that is falling on the mirror, the ray of light that is hitting the mirror, that ray of light is known as the incident ray. Incident means that this is the ray that is actually hitting the mirror. This is the ray that is starting the entire thing. This is the ray that is starting the entire thing, right? So this ray, the ray that is falling on the mirror, is known as incident ray. And the angle that the ray makes is known as angle of incidence. Now, please notice that the angle I have drawn is with the normal. It is not with the mirror. This is not the angle of incidence. That would be marked incorrect in the exam. You guys will lose marks for that. This is the angle of incidence. Okay? This always has to be with normal. Always, always, always. Never forget that. And what is the normal? The normal is the imaginary line that is at 90 degrees to the mirror or whatever your reflective surface is. So this is the angle of incidence. So what happens that the light is hitting the mirror and then it is getting reflected back. Okay. So the other ray, the other beam of light is known as the reflected ray because it is being reflected back. So we call this the reflected ray. And the angle is known as the angle of reflection. Again, the angle of reflection, just like the angle of incidence, they are both with the normal. Do you see how both the angles I've drawn are with the normal, not with the surface of the mirror? That is important, right? You always have to make sure you do the correct labeling. And do remember this. Remember this one point. The angle of incidence is always equal to the angle of reflection. The angle of incidence is always equal to the angle of reflection, meaning that this angle and this angle will always be equal to each other. This angle and this angle are always going to be equal to each other. Making sense? Muad, Sasha, any confusion, any part of this that's not completely making sense?
It makes sense.
Okay. Muad, all clear?
Yeah, okay.
Okay, all right. Now, when we are talking about our waves, right? So, remember how I said that we can use a mirror to look at objects, right? Like I can use a mirror to look at an object that's far away from me. So how can you do something like that? Let me give you guys an example of somewhere where it is done quite commonly. It is done quite commonly in something that we call a periscope. What is a periscope? A periscope, you guys have, you guys have dealt with, you guys not haven't dealt with, but you guys have seen submarines, right? Especially in your cartoons, in your movies, you guys have seen submarines. So inside the submarine, they have a scope, right? You guys must have seen it. It comes out of the submarine and then they use it to look all around, right? Outside the submarine. That's a periscope. Now, a periscope is made up of a series of mirrors, not a series, but it's made up of a couple of mirrors that are placed in such a way that we are able to see objects that are far away from us, right? This is how a periscope actually works. So a periscope works like this, that, okay, so let me just quickly draw it 1 second. Like this, okay? This is what a periscope looks like. You've got two mirrors, okay? One mirror is placed over here on this corner, and one mirror is placed over here on this corner. Okay, now you have, this is the and this is your, for example, let's say this is the water level and we're in the submarine and we're trying to see something outside. So what happens that over here outside is my object, whatever object I'm trying to view. Now what happens that the light that is coming from the object is going to hit the first mirror. When it's going to hit the first mirror, what do we know? What have we just studied? That whenever it's going to hit a mirror, it's going to be reflected, right? And angle of incidence is going to be equal to angle of reflection. So the wave is going to be reflected. When the wave gets reflected, when the light gets reflected, it hits the second mirror. When it hits the second mirror, again, it's going to get reflected. And angle of incidence is going to be equal to angle of reflection. So it's going to be reflected back. Going to be reflected back. It is going to go where? It is going to go in my eyes. Wherever my eyes may be, it's going to go in my eyes. And that is how you can observe the object. That is how I can observe what the object is by using a series of mirrors. So this is one of the ways that we use reflection in our daily lives. This is one of, not daily lives, but this is one of the applications of reflection that we have. All clear, right? Any confusion? Sasha, Mohan?
No.
Okay. All right. Now, so the second, so how many properties have we done so far? We have done two. One property is diffraction. What happens in diffraction? In diffraction, the light wave, or not necessarily the light wave, the wave is going to bend around the obstacle or whatever your gap is going to be, right? Now, another really important property that we have to understand is refraction. Okay. I have already given you guys an idea of refraction, right? What is refraction? Remember over here when I gave you guys the example of how the when you place a pencil inside the water, it appears to be bent. That is because of refraction. Now, what is actually happening? Let me give you guys, first, let me give you the very basis of refraction. Let me just explain it to you guys what it is, and then we will go into details and all the fancy definitions and everything. Quite simply put, waves, what is air? Air is a medium, right? It's a medium. Water, medium. Glass, medium, right? All of these are mediums. A wave can travel through a medium, or it can travel without a medium. For example, in space we don't have anything. Space is empty. So space is, there's no medium. Then we can have medium, which is, any particles that are present. Air, water, glass, whatever, anything. So what happens is that when we talk about a wave, okay? So now think of it this way. Sasha, you and I discussed the sound wave, right? In our last class. I told you that how does it sound? Yeah. Yeah.
Yeah, we did that.
Yes. So what we discussed that when I speak to you, the particles are vibrating, right? And as the particles are going to vibrate, what happens? The energy from the particles vibrating travels to you, right? And that's how you can hear me. Now, think of it this way, that air is a very light sort of a thing, right? Air is pretty light. It's like really less dense. It's so light. Now, so when we talk about it, my voice is going to carry to you at different speed. Now, imagine that I am speaking to you, but through a glass. Now, inside the glass, the particles are much closer to each other, right? The particles are packed much closer to each other. So, and how is the sound wave traveling? It is traveling due to the particles moving, right? So, when you talk about how fast that wave is moving, that wave is going to move at a different speed in air. When the same wave it goes to glass, it's going to move at a different speed. Same wave traveling through water, different speed. Okay? So waves have different speed depending upon what medium are they traveling. If the light is traveling through glass, different speed. If the light is traveling through air, different speed. If the light is traveling through water, different speed, right? So all waves have different speed depending upon the medium. Now, what is refraction? Refraction is when a wave goes from one medium to another, meaning that the light wave was happily traveling through the air. Then it encountered, for example, a piece of glass. So now it has to go from the air to the piece of glass, right? So the medium is changing. The light wave has to go from air to glass. The medium is changing. As the medium is going to change, the speed of light also has to change. Because in every specific medium, waves have different speeds. And as the wave is going to change its speed, it is going to bend. And that is refraction. That is why I told you guys at the start of the lecture that when you place a pencil inside the water, it appears to be bent, right? This is the reason, because when the light is traveling through air, it's traveling at a different speed. When the same light, it starts to travel to water, to the glass, it travels at a different speed. And because the speed of the light is changing, the speed of the wave is changing, the light appears to bend, and that is refraction. That is what refraction is. That is like the really basic concept of refraction that we can grasp. Refraction is the bending of a wave due to change in speed as it travels from one medium to another. Okay, that is what refraction is. Diffraction is also bending of waves, but bending of wave due to a gap, due to an obstacle. Just think of it like this, that we have, like I give you guys the example of a tank of water. So if I place a rock in the middle of the water, the rock is going to go around it, right? It's not going to go through the rock, it's going to go around it. That is diffraction. The wave is bending, but because there is some kind of gap or some kind of obstacle in the way. Refraction is also bending of the wave, but it is because the wave is going from one medium to another, so the speed of wave is changing, right? And that is refraction. And reflection is when the wave is going to, reflection is when the wave is going to hit any reflective surface, whether it's a mirror, whether it's some kind of, shiny glass, whether it's some kind of metal piece, doesn't matter. It hits a reflective surface and it is going to be bounced back. That is going to be reflection. Right? So far we're all clear. Muad, Sasha, all clear, no confusion, any part that's not making sense? Muad, is everything all clear? Any confusion? Muad, is everything clear?
Yeah.
Okay, all right. Now, uh, when we talk about our reflection, okay, let's take a simple example, refraction. Sorry, let me give you guys a simple example. Okay, the simple example I am giving you guys is this: that you are standing in front of a window. Hmm? You guys are standing in front of a window. This is air. Okay, this outside is air. In the mirror, we have the glass. The window is made up of glass. and then inside your house you have air again. Okay. Now, what is going to happen? What is refraction? Refraction is this, that this is the ray of light. Okay. The ray of light is going to hit the mirror. Okay. Now, we are going to, whenever we are talking about light or waves in general, please never forget to make your normal. Normal should always be there, especially in your ray diagram. Okay? A normal should always, always, always be there. So, when you take your normal, right, the normal has to be present. Now, when the light is going to hit the mirror, hit the glass. Now, what is going to happen that the light is going from one medium to another. Okay. Air is less dense, right? Air is less dense. Air has less particles, right? The particles are more spaced apart. Air is gas. Air is less dense. Right? A glass is more dense. So what is going to happen that as the light is going to hit the mirror, it is going to slow down, right? Because there are more particles in its way, because it has to deal with more particles. So it is actually going to slow down. Since the light is going to slow down, what is going to happen? What's going to happen is this, 1 second. What's going to happen is this, that the light is going to change direction. Okay. The light is going to bend because it is going from less dense to more dense. So since the medium is changing, since the material is changing, the light is going to slow down. And as the light is going to slow down, it has to change direction, right? Because its speed is changing. So as its speed is going to change, it's going to change the direction. So it's going to change its direction like this. In fact, give me 1 second. Let me draw this slightly there. Now, notice something very interesting. If you guys take a look at the diagram that I have just made, you guys will notice something quite interesting. You will see that if you look at the angle of incidence, right? If you look over here at the angle of incidence, so you guys will see the angle of incidence appears to be quite large, right? Now look at this. Look at the angle of refraction, not angle of reflection, angle of refraction, right? I is the angle of incidence. R is the angle of refraction. Now, what is happening? You guys will see that the light appears to come closer to the normal, right? You guys see that initially the angle of incidence was wide. Then it moved from a less dense medium to a more dense medium. And as it moved from a less dense medium to a more dense medium, the ray of light bent. Why did it bend? Because there was a change in speed. The material it's traveling through is changing. So its speed will change. But as its speed is going to change, do you see that the angle of refraction, the light wave, it has bent in such a way that the light wave has moved closer to the normal. The light wave bent. It did bend, but it moved closer to the normal. This is important. Okay. Remember this one tip. It will help you make your diagrams very easy. When the wave moves from less dense to more dense medium, it will bend towards the normal. The angle of incidence is greater than angle of refraction. In this case, not always, in this case, when it's going from less dense to more dense, the angle of refraction will be less. The light is going to go towards the normal. Okay, now the light travels through the glass. Now it's hitting another boundary, right? The glass is now, it has traveled through the glass. Now the light has to come from the other side of the glass. As it has to come from the other side of glass, again we are going to have our normal, right? Normal is necessary. We cannot work without the normal. This is going to be my normal. Now, as the light is going to hit the normal, what is going to happen? What's going to happen is this, that the light is again going to bend. But this time, when the light is going to bend, it is going to bend towards, not towards, sorry, away from the normal, right? The light, when it's going to hit the mirror, it is again going to bend. And this time, when it's going to bend, it's going to bend away from the normal, right? Why away from the normal? The reason it's going to move away from the normal is because now it is going from a more dense medium to a less dense medium. Now it's going from a more dense medium to a less dense medium. So the light is going to move away from the normal. Okay, this is the angle of incidence, this one, right? This is the angle of this incidence, and this is the angle of refraction. Again, let's see go over it again. What is happening over here? What is happening over here is this. This is the ray of light that is coming from the outside. It's coming from the sun. It's coming from whatever you're looking outside your mirror, outside your window, sorry. The angle light is going to hit the glass. When the light hits the glass, it's shifting from one medium to another. So the speed is going to change. If the speed is going to change, it has to bend. Where will it bend? Will it bend towards the normal or away from the normal? Towards the normal. Why? Because the light is traveling from less dense medium to a more dense medium. So it's going to bend towards the normal, not away from the normal. It's going to bend towards the normal, right? Then, once the light has entered the window, it has entered the glass, it will continue traveling happily. But when it's going to hit the other side of the window, it now has to change direction once again. Why? Because again, it is shifting medium. It's now traveling from glass to the air. So it's shifting medium. So it again has to change direction. But since it is going from a more dense medium to a less dense medium, it is now going to move away from the normal. It's going to move away from the normal. Okay? And when the light wave is hitting the glass, this is the angle of incidence. Okay? And this is the angle of refraction. Once the light has entered the glass and it hits the second boundary, it hits the second surface of the glass, what is going to happen? This is going to become the angle of incidence and this is going to become the angle of refraction. And when we are talking about what is going to happen when the wave moves from more dense medium to less dense medium, it will bend away from the normal. In this case, where the wave is going from more dense to less dense, what is going to happen? What is going to happen is this, that the angle of incidence will be will be larger than the angle of refraction. Same thing. I'm so sorry. Opposite. The angle of incidence will be smaller than the angle of refraction. And this is why that uh, pencil that you guys have put inside the glass, it appears to be bent. Because the light wave, it travels through the air, into the water, through the glass, and then it comes into your eye. So the light ray is getting bent, right? And when it finally hits your eye, since the light ray is getting bent, it appears to be, look over here. Let's say that this is the object that you were looking at. This is where your eye is. So it appears to be bent, right? This is known as refraction. This is this is a really important concept that you guys have to study. Like, this is a very important topic of waves. You get a lot of questions on this. Is this clear? Is this part making sense? How refraction happens? If there's anything at all, even if there's a small thing that's not making sense, let me know. We'll go over it again because this is an important thing that you guys have to be completely clear of. Any confusion? Any part that's not completely clear? Yeah, Sasha, go on. Is there any part that you want me to go over again?
So like when it's more dense, it like
Yes.
will bend towards the normal.
Yes, exactly.
And then the angle of incidence is greater than the angle of refraction.
Yes, exactly.
Okay.
See? And then when it goes from more dense to, it's going from less to more. When it goes from less to more, they're both opposite of each other, okay? In less to more, it goes towards the normal, okay? So the angle decreases. Angle of incidence is larger, angle of refraction is smaller. Then if you go from more to less, that's the opposite. Learn it as opposites, okay? Less to more, you will move towards the normal. The angle of refraction will become smaller than the angle of incidence. Then if you go from more to less, that's the opposite. So you'll move away and the angle of refraction will be larger than the angle of incidence. Okay, so the angle is going to, they're both opposites of each other. Less to more, the angle becomes smaller. You become close to the normal. More to less, the angle becomes larger. You move away. Okay? Clear, right? No confusion?
Yes, I understand now.
Okay. Mohan, is everything clear? Any part that you want me to repeat?
Oh, no, it's clear.
Okay. Now, another really important concept that we have to go over is now every piece of material will bend the light or it will bend the wave a certain amount. Okay. Water will bend the water will bend the ray of light a certain amount. Glass will bend the ray of light certain amount. Water, for example, I'm not saying this is how it is, but water, for example, might bend the ray of light more, right? Glass, maybe it will bend it less. Or if you have a thick piece of glass and you have a thin piece of glass, or if you have, different types of materials. So every material will bend the ray of light a certain amount. Some material will bend the light more. Some material will bend the light less. This property is known as refractive index. Okay? This property is known as refractive index. What is refractive index? Refractive index is simply the amount by which a material will refract or bend the ray of light. Okay? So every material has a certain amount. How much amount of light it will bend. And the reason why every material will bend the wave by a different value is because of the fact that every material has its own density, right? Every material has a different number of particles. So depending on that particular feature, the light is going to change speed by different amounts. In one piece of glass or in one material, it will change its speed more. It might slow down a lot. In another piece, it might only slow down a little bit because the material is made up that of in that certain way. So that amount by which a material will reflect or bend the light is known as refractive index. So actually, if you compare water and glass, glass usually refracts the light more. Okay, glass will bend the light more. Water will bend it less. That is because they've got different properties. So that is known as refractive index. Refractive index is denoted by the symbol N. Okay, N stands for refractive index. Now, there's a formula of refractive index that we use to calculate right? In fact, there are two formulas. Okay. First formula that you guys need to know about is sine I over sine R. Sine I, the I stands for angle of incidence. So if you take the angle of incidence and you take out the sine of it, right? You guys know your trigonometric functions. If you guys don't know your trigonometric functions, let me know. I will go over them. So you have your sine, okay? The sine of I divided by sine of R. Okay? You divide the two of them and you are able to calculate your N. What is N? It is the refractive. This is why over here, when you guys look at my diagram, if you guys look at my diagram over here, see that the labeling of I and R changes. Okay. For the first, this is your I. Okay, when the light is coming towards the glass, this is the incident ray. This is the incident ray. Okay, this is your incident ray because think of it this way: incident ray is always the ray that is traveling forwards. Okay, so this is the incident ray, and this is the refracted ray. Okay, now when the light has entered the glass and it hits the second boundary. It hits the second surface. Now, this is not the refracted ray. Now, this is the incident ray. Because the light has entered in the glass, it refracted, yes. After refraction, it continued to travel normally. Now, when it hits the second surface, we're not going to call it the refracted ray. This is now the incident ray because it has already been traveling through the mirror. It has already been traveling through the mirror. It has already undergone refraction. Now it is hitting the second surface and it's going to refract again. So the terminologies change. Okay, this is the angle of incidence. This is the angle of refraction. If we talk about the first boundary, okay, if we talk about the first boundary, this is the incident ray and this is the refracted ray. But when we talk about the second boundary, this is the incident ray because now this is the ray falling and this is the refracted ray. So when the light is coming towards the glass, this is the angle of incidence and this is the angle of refraction. But as the light enters the glass and then it moves out of the glass, it changes. This is the angle of incidence and this is the angle of refraction. Why am I again and again and again emphasizing on this point? The reason is that if your labeling is incorrect and when you put it in the formula, you will not get the correct answer. If you call this the angle of incidence and you call this the angle of refraction, then when you put the values, you will get an incorrect answer. So learn this diagram basically. Okay. Now, this is one formula of refractive index that is important. Another formula of refractive index that is important is speed of light in medium divided by speed of light in air. Okay. By the way, the speed of light in air is fixed. Okay. In air, the speed of light is fixed. Okay. The speed of light in air is 3 into 10 raised to the power of 8 meters per second. Okay. This is a fixed value. This is a value that I want you guys to learn. Okay. This is a value you guys have to learn. This value is really important. This value is going to come again and again and again and again in a lot of your topic of waves. Okay. So please learn this value. The speed of light in air, the speed of light in space, the speed of light is 3 to 10 is to the power of 8. I will explain this value a bit more when we do the topic of electromagnetic spectrum. I'll explain this to you guys. But this is the speed of light in air. This is fixed. So what you can do is that you can take the speed of light in air. You guys know the value. If you guys are given this in the exam, do not worry. You have the speed of light in your mind. Okay? So speed of light in air is this much. We know the speed of light in the medium, in the glass, whatever. You can calculate, right? You guys are physicists, scientists, whatever, can calculate. You divide the two value and you can calculate the refractive index. So there are two formulas that you guys can use to calculate the refractive index. Clear? Any part that's not making sense? Any confusion that anybody has?
No, it makes sense.
All clear? Muad, is everything all clear?
Yes.
Okay, perfect. Okay, so guys, we're going to go ahead and we are going to stop it over here for today. Now, in our next class, we are going to go over the total internal reflection. That is a very important property of light that we have to talk about. Okay. Then after that, we're going to go over some past paper questions and we're going to have a small quiz as well. Okay. We're going to have a small quiz. We're going to finish the topic and we're going to go over past paper questions. So make sure that everything we've done in today's class, you guys go over it. Okay. Any questions? Anything that anybody wants to ask?
No.
All right. Okay, perfect. Thank you so
Okay,
much,
bye.
Asha and Wad. I'll see you both in the next class. Have a good
Bye-bye.
day, guys. Love.
Thank
Bye.
you.
Okay, bye.
Bye, Muad.